Hi, I'm Dr. Lyndon Walker. The following video is part of my Skillshare course, Getting Started with R. Here behind me you can see the various different chapters of the Skillshare course. You can click on the link below the video to take you to the Skillshare course, and you'll be able to download the data that I use in this video and work along with it. In this video we will look at some of the R functions that we would use to produce some tables and some descriptive statistics. So there are many different ways of doing this, and since this is a beginner's course, really going to look just at the very simple basic ways of doing it. So we will look at how to produce a table, either a one-way or a two-way table for a categorical variable, and we'll look at the mean and standard deviation and the 5-number summary for a numeric variable. In more advanced courses, we will look at how we can slice the data up and produce more meaningful and more interesting and more complex descriptive statistics. But for today, we're really just focusing on getting these basics. In our previous sections, we imported the AIS data into R. We have this AIS data frame with various different variables. And then we use the head function to look at the top 6 rows. Now we are going to look at some descriptive statistics. So these are very simple ways of doing this. There is certainly more complex ways that will produce nicer formatting and more elaborate sets of statistics. But I'm going to leave those for a more advanced course. Here, as beginners, we're really just trying to get some simple output. So we can use the table function to create a table of counts for a categorical variable. So we've got table, we know it's a function because we've got these round brackets, and then we're referring to the variable that we want. So it's the AIS data set, and then the $, and then sex. So we can hit run, and we can see that we have 100 females and 102 males. Let's suppose that we wanted those as proportions. So there is another function called prop.table, and it will take a table and then convert that table into proportions. Anytime we produce anything in R, we can assign it to an object. So here in this line, we are going to make a new variable sex table, and then we've got our assignment arrow, and we've got the previous code that we had, table, AIS data. It's going to make a new object called sex table. And sex table is just storing this table. Then we can use the prop.table function. We can give it sex table, and it gives us the relative proportions. So 49.5%, 50.5%. So this is a nice way of being able to quickly produce tables. We can see that it doesn't format things particularly nicely. As an advanced user, we might use Markdown and actually produce a document with nicely formatted tables. Alternatively, we can just take these figures and put them into Word or whatever data word processing program we are using. So that is how we would get a table for a categorical variable. Let's scroll down, and let's suppose that we wanted the mean and standard deviation for a numeric variable. So one of our numeric variables is body fat, and so we can use the mean function. We've got AIS data, $, and the body fat was stored as x.bodyfat. The x dot ended up in there, which seems a little bit funny, just because I think in the original data there was a percentage sign, and it wasn't going to accept the percentage sign, so it replaced it. So we can hit run, and we can see that the mean body fat for these athletes is 13.5%, which is certainly quite a bit lower than someone in the average in the general population. So the function to get the standard deviation is SD. So we can run this, and we get a standard deviation of 6.19. So by itself, that's not overly interesting. Normally with standard deviations, we would be splitting this up perhaps across gender to see whether there is a similar standard deviation or spread amongst data from different categories. The last function that we're looking at is the summary function, and if we run that one, we see that it gives us the 5-number summary, so minimum, first quartile, median, third quartile, and maximum, and it also gives us the mean again. So it gives us those 5 figures for us to get a little bit better idea of how the data is spread out. Those are the figures we would be seeing if we produced a box plot. And these are things that we would most likely be putting into a descriptive statistics table, and so we would probably be running these code across a number of different variables, and these would all end up as descriptive statistics in whatever we are reporting on. Thanks for watching this video. Please like and subscribe to support more academic content for Masters and PhD students who are embarking on their research journey. Also, see below the video for links to our YouTube, Facebook community and Skillshare.